GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Hey everybody, welcome to the Google Maps office hours. This week is Mars Mania because we've been doing a lot of chatting, a lot of excitement around the office about the Curiosity landing, and we've been looking at kind of interesting ways that we can actually integrate that into our work, because I think otherwise people got kind of a little annoyed hearing us talk about it all the time without any real kind of anything to show for it. So what we did is we went through and we kind of thought about different ways we can actually use the information and the imagery that's coming from the Curiosity Rover and some of the other imagery that's available for Mars, and do interesting things with the Google Maps API. So we've done two things for this week, and there's a lot of other things that we've been playing around with, and we might be able to show it a future day. One is actually we did Street View imagery of the panoramas that we got from the Curiosity Rover, or the panorama that we got from NASA of the Curiosity Rover. And the other one is actually looking at some of the elevation data that we got from one of the other satellites. Which one was that? That was the
Mars Reconnaissance Orbiter.
Yeah, the MRO, and seeing if we could do actually elevation analysis using the Google Maps APIs. So, we didn't introduce, I think everybody knows you at this point. Brendan?
Yeah. Hi, I'm Brendan Kenny.
So Brendan's been working on the elevation data. I've been working on the street view. And a couple logistic things real quick. What we usually we set up a moderator so that people can actually submit comments. We didn't do this week because we found that people were putting comments pretty much all over the place, either on YouTube or on Google Plus or in moderator. So if you have any questions and you want us to look at them either today or after the session, either put them on the YouTube or Google Plus, and we're going to take a look at those a little bit later. So in terms of Street View, I guess we'll start with what we did with Street View. So basically what NASA did is they did a stitching of some images that they took from the Curiosity Rover, and they made a complete 360-degree panorama. And with that panorama, what we were able to do is actually put that into the Street View service to actually look at that as we would Street View. Just as Street View itself, it's not super interesting. You can just kind of pan around and kind of zoom in and out of the image. But what's really curious is that when you can kind of layer things on top of that. So what we're going to do today is I'll show you kind of what we did to get the imagery into Street View, and then we'll talk a little bit about some of the extra stuff that you can add on. And then in terms of the, what were you going to like to talk about today with the?
I think just take a look at taking the imagery, which is in kind of a weird format, and just bringing it in a format that we can use easily, and then just importing it and using kind of WebGL to display it in real time. Unfortunately, the really high-res imagery of where the Curiosity lander is right now is not coming for 2 days. So we timed our hangout 2 days early, but we do have lots of other imagery of Mars that we're able to take a look at, and then hopefully in 2 days we'll be able to post the I think it's down to 24 centimeters per pixel resolution of the landing area in terms of elevation. They've already published imagery itself of the area.
Yeah, so this Mars mission really, it's a lot of there's a lot of imagery coming out just because they've had a lot of really good cameras on the rover and the satellites both, and so it's a great opportunity to kind of play around with it. And there's actually been other people that have been looking at this as well. We saw recently there's I'm going to forget the website off the top of my head, but it's somebody actually did a panorama very similar to what we're going to show in Street View, but a little bit different. It's not using Street View technology. So why don't we kick off? We'll show you. Well, actually, let's cover a little bit about the imagery. So the image that we got from NASA, it's actually rather large. It's about 30,000 by, I think it was about 4,000 or so pixels. So it's a very high resolution image. It's a composite of quite a few images. Like I said, they stitched them together. And what we did is to get it into Street View imagery, we actually expanded it out horizontally vertically, to include some kind of letterboxing. And that just allows us to put it in a 2x1 format. And what I can do right now, so I'm going to show you on the screen here. That's not the one I want. So this is what the original image looks like. This is zoomed out pretty far. You've probably all seen this if you've been following the Curiosity mission. And this is a very, like I said, a very high resolution image. It's about 30,000 pixels wide. So as you can see, if we zoom in, it actually maintains quality quite far in. I mean, you can actually see pretty good detail on even these rocks that are kind of in the far distance.
You can see why I started naming the rocks.
Yeah.
Well, if this is all you have to look at.
Yeah, we have names for rocks, and we have names for the scorch marks. They've pretty much. I was looking actually for names of some of the other, like the mountains in the distance, and I didn't find any that were necessarily correlated to this image yet. But if anybody has any,
well, the big one is Mount Sharp.
Yep.
And then there's a much better name. That's a Greek, something about wind, but I don't remember what it is.
Oh, Galus?
No, it's the other one.
I gotcha.
Anyway.
So like I said, what we did with this image, since this obviously isn't in a 2-to-1 aspect ratio, it's actually quite a bit longer than it is high. We actually padded it out to make it a 2-to-1 aspect ratio. And this is what it looks like here. The reason we did that is actually it's a lot easier to manipulate in when we're doing the tiling and actually the setting things up for the street view. You don't have to. You can actually go. You could actually tile up the original image. But you're just going to have to be careful because since it's not in a kind of an even aspect ratio, you might end up with kind of odd-sized tiles, or the tiles might actually overlap if you don't get the calculations right, or you might not have enough image to fill in the entire the tile around the edges. So we padded it out, and it just so happens that the 29184 is the actual length of the image. It's very easily divisible by 16, so that ends up being about 1824 or 2,000 pixels. So we took that. The reason we took 16, okay, we'll take a step back. And with the street view, the way it works is, let's just go to the image and show you what it looks like. It's a lot easier. So here's actually that same image actually in street view. You see a couple markers here, which we'll talk about in a little bit. But you can see this is actually just like street view you'd see with on the Google Maps product, or you can do with any other panoramic images. And what we did, so like I said, we put this in street view, and we tiled it up so actually we can maintain the resolution of the image, or the quality of the image. So we couldn't just take the 30,000 pixel by 15,000 pixel 2-to-1 aspect ratio image that we produced and drop it directly into Street View. We had to tile it up, and tiling is the same process that you use for maps. So as you zoom in, instead of actually zooming in that entire image and scaling the entire image, what it'll do is it'll just load what tiles are relevant for the current viewport. And you can see by doing that, I can't find the exact rock we were looking at earlier, but we'll find another one. There's plenty of rocks out there. As we zoom in, you can see that we actually are maintaining pretty much the same quality that we had with the original image. And that's just because we were able to, what we did is we tiled it up and we made it a little more efficient for the system to actually deal with the images.
You scroll down to the scorch mark.
The scorch mark, you want to see the...
It's pretty cool.
I think these ones definitely have names. I can't remember all of them. I have a couple of I have a couple of them, the names. That's what the markers were earlier. So what I'll show you first is so the code that I used actually to do the tiling. So originally I tried to use there's GDAL. It's actually a tool, an open source tool for actually doing maps tiles. And I ran into a little bit of difficulty actually getting that running on a Mac. I put it on a Linux workstation instead. I ran it there. Everything seemed to work fine, but had a little bit of trouble getting the images looking right. So what I did is I just defaulted back to bash scripting and using ImageMagick to do the tiling. And so what I did for the tiling is I'm taking the original image, so that's our full size, what we call in the maps, the Street View API, the world. So I'm cropping the entire image, so that's our maximum zoom. And I'm doing that at 16 by 16 tiles, which ends up about 2,000 by 900 pixels per tile. at 2:1 aspect ratio tiles. So they're not square tiles. And then for the other zoom levels, so as you're zoomed out from the full zoom, I'm just dividing by 2 each time. So the next resolution is 8 by 8. And I actually did write that down. 8 by 8 is about 4,000 by 2,000 pixels. 4 by 4 is about 2,000 by 1,000 pixels. And then 2 by 2, 1,000 by 512. And actually do all the way back to 0 zoom, which is 512 by 256. So the first thing I'm doing is I'm actually producing, taking that original image and actually scaling it to all of those individual resolutions. So, and then I can, for the different zoom levels, and then tiling up those using the constant tile size of 1824 by 912. So if I look at the code again, so here basically I'm saying, taking file input, identifying the, let me zoom that in a little bit more so hopefully everybody can read it. Getting my tools in shape. I'll come back to this in a minute. The MPC file format, which is something specific to ImageMagick, is very useful, and I'll talk about that in a minute. Here I'm specifying my zoom levels, the maximum number of tiles. That's for the full-size image. I use that information a little bit later. I'm getting the full image resolution out using the identify command, which is ImageMagick tool, and calculating the tile widths and heights based on the full-size image and the maximum zoom level. And then what I'm doing is I'm just looping through my the zoom levels that I want. So I'm going to go from 0 to 4 zoom levels. And there's a really interesting thing to note about the zoom levels. The zoom levels don't necessarily correspond to the controls on the street view. So the street view controls can have zoom levels from, I don't know what it is, I think it's maybe about 6 different zoom levels. But what the API does, it actually optimizes. So if you have a really small viewport, it can actually use a higher zoom level for the tiles. So it's a little counterintuitive, but if you play around with this a little bit, you'll eventually kind of see what it's doing. And then so I'm going through each of the different zoom levels. I'm calculating the width and height for the image for that zoom level, the full-size image for that zoom level. And I'm calculating the number of tiles that I'm going to need for that zoom level. And since I do have 2:1 ratio tiles and 2:1 ratio image, I can just use the same number of tiles horizontally and vertically. And then I'm doing a conversion. And what this conversion is doing is taking that original TIFF image, which is really uncompressed, rather large, and pretty hard to deal with actually in terms of doing cropping and tiling. I'm converting it to the scaled image, but using the MPC format for ImageMagick. And like I said, that MPC format, what it does is it allows you to, it's an optimized format for ImageMagick so that they can actually index pixels as opposed to actually having to uncompress the original TIFF and kind of work back from there. So it makes the actual conversion a lot quicker. And I was seeing, before I was using MPC, I didn't know about it originally. The conversion was taking, or actually doing all the tiling for 0 to 4 zoom levels, it was taking maybe about half an hour or more. Or actually, I think it was even longer. I think we went to lunch, it was maybe more than an hour. With the MPC format, doing the 4 zoom levels, it's pretty straightforward. And then I'm actually doing the tiling. So I'm going vertically, horizontally, and just sampling out or cropping out different tiles and saving those to files. In the JavaScript code, or in the HTML code, I'm going to switch over to here real quick. This is actually going to look a lot like some of the samples we have for Street View. I pretty much just picked those out. The big differences here is what you do is you specify custom tile URLs. So, and this is actually something that you specify when you set up the Street View options. I think it's way up here. Oh no, I'm sorry. So when you set up the panorama options, you specify the panorama provider, and the panorama provider actually includes the method that includes the method for getting the custom tiles out. So you can have multiple tiles or multiple panoramas in one display, and the same code can be reused. So, and what I did here is I'm just saying that I want to use tile with a particular zoom level, the tile X and tile Y. if we go down here, this I didn't find this super intuitive at first, but the world size is actually your original image size or the full size image. And then you have to specify your tile size. And this is how the Street View API actually optimizes. So, I mean, pretty straightforward. The other stuff that I can show up here.
Yeah, will you show us your markers?
Yep. So let me we'll go back to the actual Street View that I showed you before. So these are kind of fun, and this is stuff that I was working on pretty much yesterday. But since this is Street View, some of the advanced features that you can add over just a standard kind of image viewing tool is that we can add markers on the display, and these markers, they look really small, and I'll talk about why that is in a second. But you can add markers to the display. You can add info windows, and I think you can also do custom overlays or overlays on top of the Street View as well. I think we showed a couple weeks ago, Brennan, you had that overlay view with the three-dimensional stuff.
Oh yeah, yeah. Well, that's a very custom overlay. But it's nice because if you have your map content, I mean, if you've ever used the Street View API before, and then you switch to the Street View, the same content is there. We just don't have an overhead view of Mars. I guess we could have made one.
Oh right.
What is Do you know what Burnside Scour is named for?
Oh, that's a good question. I didn't look that up. I'm going to assume it's somebody's name because this one I think is called, the one on the right is called, I feel like I should know this, Goldburn Scour. And actually there's two other scours on the other side.
Are they both named Burn? Is that like a joke, do you think? Because it's like a rocket? Never mind.
So another thing that's kind of fun with these markers is these are just map markers, so you can do things. I mean, they can be animated. I didn't animate it because the animation's a little funny here, because they are actually zoomed pretty far out. But you can actually make them draggable, and this is why they're actually pretty small, because they're pretty far out, or the scour is actually relatively far out. So these markers, you can make them draggable. You can move them around, and this is actually how I identified the latitude and longitude where to mark these. Because the latitude, I have the latitude and longitude for actually where the lander landed, but I didn't have the latitude and longitude for the scours. Data's probably out there somewhere, but so yeah, so you can put the markers on here. So the other thing that we can do in the future with this is, as we do get more imagery, we can actually do actually like the Street View. What do you call that when you're moving from kind of panorama to panorama? So if we have multiple panoramas, we can actually say, well, this is the route of the rover. You can follow the route, and every time it takes a panorama, we can put that in here as well. I don't know if we're gonna.
I really want to do that.
Yeah.
So, I might not one day when there's like thousands of them, I might not do it, but I want to do it at least once.
Yeah,
or
I think that would be a lot of fun.
I'm not sure when it's supposed to start rolling, but I think it started moving a little bit, but it's mostly just kind of moving in place while they figure out all the wheels and the motor situation.
Yeah, and I did see there was, I think, another black and white panorama that came out very recently. So the panoramas are going to keep coming. Oh, they also have the deck imagery. You could stitch together quite a bit more. I mean, with the deck imagery, I think that's how I was mentioning before that somebody actually did a full view panorama. And what they did is they actually simulated the sky. So they did simulated sky up on the top. And I think they also took the deck imagery, and they put the deck imagery along the bottom.
Yeah, I found that a little strange, but
yeah, I mean, it was.
Well, there's just a lot of simulated imagery, and it was
Yeah, I mean, I think from a kind of artistic standpoint, I think it was really really great thing. And I mean, it is kind of an immersive feel. So one thing that I found, and I've been kind of toying around with a lot with the Street View API, is that the bigger this window gets, actually the performance actually degrades somewhat. So that's one thing you really want to keep aware of. And what I actually tried is tried to use multiple different tile sizes. I tried to make the tiles really small or actually blow them up quite large. Kind of the performance kind of hit was always there as I made the viewport larger. So good viewport size I found about 1024 by 768. This one I think might be about 800 by 600.
And it varies somewhat by platform.
Yeah, that too.
Because some browsers have accelerated canvas, and so you get like super smooth performance, and then some browsers rely on the what's called HTML4 mode, where it's just kind of displaying the tiles directly, and so it might be a little bit slower. And until kind of all the browsers catch up to more modern techniques of drawing things, then we're going to have that kind of spread in performance. But it is nice, and I think the thing I want to most emphasize with this is how easy it is to do a custom street view. I think with kind of going into it and making a bunch of tiles, it does become a little bit harder, a little bit more work, but it's actually not very much work, and it's a skill, especially if you want to get into more complicated mapping applications. Like being able to make tiles at the drop of a hat is a very important skill, and so it's a valuable thing to invest your time in and to learn. But once you have those tiles, it's really it's dead simple. The API is very simple. Actually, I think it's one of the more elegant parts of our API, and at that point, you can have all the custom panoramas you can think of.
Yeah, so we'll post. I mean, a lot of the code that I got, the bash script that I put together, was actually pulled together from some sources on Stack Overflow. The trick with using the MPC files actually was a trick I found on Stack Overflow. We'll either post the code out on Stack Overflow or maybe in the Google Plus following up, so that you guys can take a look at it. So what?
I don't know if I'd be brave enough to post one of my bash scripts.
Yeah, bash is a kind of an art form when you're doing kind of more complex scripting, I think, but entirely useful. So I'm passing the laptop over. So in the next few minutes, Brendan's gonna switch over and show some of the elevation work that he's been doing, which is actually pretty amazing stuff as well.
Let's see if we can. Here we go. So the data I'm using comes from the Mars Reconnaissance Orbiter, as I said earlier, and so it's been circling Mars for several years now, and it's one of the most helpful ways, or one of the most important things it's doing is actually relaying information from Curiosity to Earth. But it also has some really nice cameras, and one of them is the Highrise Camera, and this is reverse scroll. And let's see, I'll just pick one randomly. And so it has super high resolution. It flies fairly low over Mars and has an extremely high resolution, capturing apparatus. I think it's actually technically a telescope. And so what it does is it's called stereophotogrammetry, which is the same technique that people use from everything from our new 3D helicopter view in Earth on mobile to things where you take multiple pictures and you can extract kind of a point cloud and a 3D model out of that. And basically what you do is you use information about where the camera was over from multiple viewpoints, identify objects that are the same in each, and then basically triangulate from each of those photos to figure out where things are in 3D space. It's the same thing our eyes do with binocular vision. So the satellite does that by actually taking multiple passes over Mars. So it goes over once, and then a few days later, or a month later or something, it goes over the same area from a slightly different angle, and from that they can extract pretty high resolution, as I said, I think down to 24 centimeters per pixel elevation maps. And unfortunately, they just took one, I think about 3 or 4 days ago, of the Curiosity area. You might have seen it. It had exaggerated color with blue instead of gray. And so in 2 more days, they're going to take another pass and have a really high resolution view of the area, but we don't have that. So I just picked a random area, and you can see the format they have here. Here's a version that turns no, that's not what I want. Color altimetry. Here's a version that turns that altitude into color. So part of the problem is that usually the elevation data is it needs more precision than the 8 bits per pixel that you usually have in a grayscale picture. So here you can tell we have a scale down here at the bottom. This varies over almost 1.5 kilometers, and so you only have 256 levels in a byte, and so you actually need more than that. And so sometimes it's 16 bits or whatever. And so this is one way of displaying it. They just map it to a color ramp, and you can see down here is the really low areas and the high areas. And there's a bunch of formats that they provide. It's extremely helpful. And if you look into it, it's called a PDS format, which I'd never heard of, and it seemed like obscure, and I couldn't find much on it, and Google was trying to convince me that I was looking for a PSD, but it turns out it's extremely common in the GIS world, and so what do I know? And so GDAL supports it, and so you can use GDAL Translate to translate from the PDS or IMG format over to basically anything you want. And so it's a little bit tricky because WebGL right now only supports 8-bit per channel images, and so really what you want to do is maybe pack into different color channels, but for now we can just go with kind of a lower res 8-bit grayscale image and deal with that. What's the best way to show this? So first you translate it into a grayscale, and it looks a lot like this. And then we use what's called the simplest way is to use something that's like finite differencing, which is a way of measuring the rate of change over pixels. And it sounds really fancy, and lots of people try and trick you and think that it's fancy, but it's not really. It's just subtraction. It's like, it's very common, like, oh yeah, I got my whatever degree in finite differencing models and modeling airflow over cars or something like that. It's just subtraction, where you're looking at the difference between two like discrete samples like pixels, and looking at kind of the angle as it changes between them. And that's all a change in elevation is the change in in heights of this thing. And from that you can figure out the direction of a surface. So now we have a surface like this. And so then if we have a light ray coming in this way and the direction of the surface is that way, that surface might be kind of dark, but if it's coming in directly at the surface, it might be lighter. And that's pretty much that's the 30-second, because we're already over time, display. So there are fancier things you can do. So one of the problems is that, just like with maps, you have to pull in a tile for every one of these, a tile for every unit of area. And if you want to pull in more data, you have to fit it into that RGBA channels. And if you want to get even more data, you're going to have to pull in another tile, and every tile is going to slow you down. So you start figuring out ways to pack in information into these tiles. Unfortunately, game developers are way ahead of us because they've been dealing with small CDs and then DVDs and downloadable games for years now. And so they have lots of tricky ways. And one of the ways I use is to pack that surface normal, which is really a 3D vector, into two components. And so you just have the RNG channels used for that. And then you still have your blue and your alpha for whatever you want. Like you can bring in other fancy data. And it's not that interesting. It's pretty much the observation that a sphere is a surface in 3D, but it's also, we can describe it with two dimensions, like latitude and longitude. And latitude and longitude are inefficient because you waste a lot of precision at the poles, so you can actually spread it back out, and it basically ends up being like a reflection in a parabolic dish, which is kind of fun. So if we go over here to the demo itself, it's less exciting after all that buildup, but here is an area, and I only extracted like 2 zoom levels, and it's somewhat low resolution, as I said, but here we have some really cool sand dunes on Mars, and it goes into some rocks over here. And I think, oh wait, no, only 2 zoom levels. Wait, there we go. You can see pretty much that's and there we have it.
So you actually did the lighting? I mean, you took.
Yeah, so the lighting is in here. Unfortunately, to enable it, we're out of time. So.
Oh, no worries. Yeah, but so the idea is really that with the elevation data, you can actually.
Yeah, you can light it in real time, and actually a really cool idea would have been like the heat shield landing and being like, well, we're going to do that. Maybe we'll do that this afternoon. But I guess it didn't explode. But we can imagine it's like a Michael Bay universe that, well.
So what we're looking at here, though, is so you took the elevation data that was in the RGB channels,
right?
And then you actually did. So where did you actually plot the lighting in this one? So
so if we look, I don't know if we really want to. So
I guess
here's the actual shaders that I'm using. So if you're familiar with WebGL, this shouldn't be a big deal. If you're not, It's not a big deal. It's just a different language that's ideally suited for this stuff. And oh, it won't let me scroll. So still won't let me scroll.
So you took those images, you loaded them in there, and now you...
Yeah, so let's see. So here's where I get the normal, which is just the surface direction. And so the actual... Well, the lighting is a little complicated because it's... I do some fancy lighting, but it's pretty much this, where we take a light direction, and this comes in from the mouse direction, which is what I would enable if we had a moment. But in the end, I just take the light direction and I take the normal and I dot product them together, which gives me kind of the angle between them, and then I attenuate that by the view. So if you get kind of this angle that would be specular, but it's pointing away from you, you get less light. So you can do quite complicated things in here. It's just up to you to kind of imagine them, and I think it'd be great to eventually show. There's no reason why you have to limit yourself to imagery. You can start looking at kind of turning this into geometry and doing some interesting things.
Mm-hmm. So this is being lit, though. I mean, the lighting, we can't do it dynamically. You can't move the mouse around to actually show the lighting, but this is actually lighting the tiles.
Yes, it is.
As it's being loaded in.
Yeah. Yeah, I mean,
we'll so I think the fun thing will be to kind of share some of the code and see what what people can do with it.
Let's see if I can drop those in here. We might be able to do this. Does that work? There we go. So yeah, so this is not exactly the most dynamic thing, but you can start. It's hard to tell, but it's actually
cool.
Changing. Anyway.
No, we get the idea.
Yeah.
So this is I mean, there's some really great imagery out there from the Highrise Camera.
Yeah, so great imagery, and we'll post the code to kind of split it up. It's not great. If there's any GDAL experts, actually we have some on our team, so I might consult them on how to get the higher kind of bit depth to the images. But you can actually see one of the problems with using orthographic imagery and lighting it. I've lit it from below now, and suddenly these mountains look like they're
oh yeah, they're embossed.
Embossed instead of actually standing out. And so there's lots of tricks that we don't think about in cartography that let you kind of play with your brain and take advantage of your brain, sometimes without you even knowing, until it looks terrible and people wonder what's going on. So
yeah, so unfortunately today we're probably going to take the questions offline, but definitely post them if you have any questions. We're going to post the code. We'll put that in either Stack Overflow or follow up in some of the comments that we have, or in the Google Plus or YouTube comments, if you're looking for something specific. And
that's better.
Well, Brendan, you're still tweaking.
Well, now it upgrades.
And yeah, so hope you guys can join us next week, or actually 2 weeks. Brendan will be back, and Brendan Mana will be around.
Yeah, in 2 weeks we're talking about some great HTML5 techniques with Mana Marks, talking about things like dragging a shapefile into the browser and having it kind of unfold on your map right there without any server intervention or anything like that. Yeah. Just interesting ways of displaying that kind of data, your existing geographic data. So join us then. We'll make a post.
Cool. All right. And any comments you have, post them, and we'll definitely follow up. Thanks a lot.
Thanks.